So obviously, I believe you guys have been able to uh, understand how to get the solution from the table. So this last question before the network had an, you can see we are trying to find less than minus 0.25. Drawing the diagram, of course, this is how it looks like. You go to your table, you check for minus 0.2 under 0.05. Of course, if you check the table, I got 0.4013, which should be the same answer you should get. Now, I was saying, if you were asked to find the probability of z greater than minus 0.25, in that case now, obviously, if this is minus 0.25, you'll be interested in this portion. Now, I told you guys already, I've repeated this so many times this night. We don't have any table that will give you a value from right to left. Right to left, it's not possible. You don't get that on your table. So what you'll be getting is always from left to right. So if you are told to find z greater than minus 0.25, you cannot get this portion from the table where you can get. So if this is what you're interested in, you go and find this one. What you get on your table, minus 0.2 under 0.05, will give you this portion. So you need to go on to now do the needful. By subtracting 1, you'll be doing 1 minus, to get the portion, you'll be doing 1 minus 0.4013. Whatever value you get here will be what will represent your z greater than minus 0.25. That's the way you attend to questions like this. All right. Now, quickly, in just some few minutes, I want to give you the understanding of how to use the positive table. All right. How do you use the positive table? Well, you can go on to quickly invite your friends quickly, because I believe some people do not know that the link is back up. You can go on to send the link to people, all right, so that they can join us in time. We'll be ending the class very soon, but I just want to touch, of course, as I initially thought we'll be able to go on with the applications, especially that of applying normal distribution to the binomial distribution, but we won't be able to do that this night anymore. So I'm just going to focus on explaining how to use the table in this particular class. Now let's assume a different, all right, so I'm going to be giving you, I'm going to be solving these same questions. I'm going to be changing some things here. Okay, let me not start with this. Let me still do the less than here. Let me do the less than here. Let me just do the less than of everyone. Let me do the less than of everyone. Now, this is supposed to be quite very simple. Now that you have understood, of course, the positive table is nothing different from negative, only that we're dealing with negative and positive. That's the only difference. The same way you deal with the negative is the same way you deal with the positive. The same attributes of it giving you results from left to right is the same thing that goes on with the positive table. Now, for you to know your positive curve, your positive table, of course, you will see a table with this kind of diagram where you shaded it up. This one was, the shading happened before the 0. Now, this one is 0. The shading will happen after the 0. But you can notice one common ground for both of them is that the shading is coming from left to right. Left to right. That's what you need to notice. Now, of course, one thing that will be different is you will see your Z values here will no longer be negative. So your Z value here, you'll be having 0.00, you'll be having 0.101. No, sorry, 0.0, then 0.1, not 0, 0.0, 0.1, 0.2, up until 3.4. You'll see that on your table, obviously on your positive table. Now, what you want to do in solving these questions you have here, I believe you guys should be able to shade this diagram properly now. So the first one we have here, the first question we have here, Z, of course, these are 0 less than 1.5. Let's call this 1.5. So we're dealing with less than 1.5. Look at the way the shading will happen. So you can see this is very much looking like this now. You can see it. So in this case now, you have to use your positive table. So to solve this question now, you're looking for this area. So this is still very nice because this area is from left to right. So you'll be able to get the result very easily here. Now, what do you do to get this? Of course, you go to your table. You're looking for, this one is just 1.5 now. So you'll be looking for 1.5 on your positive table in this case now, under 0.00. I'm sure you understand why we're doing that now. Now, if you go under your table, you will be seeing what value do you get. Can anybody give me my answer? What did you get? 1.5 under 0.00. What did you get? Of course, I want to check my own table. Of course, in this case now, you're using your positive table. So if you go under your positive table, 1.5 under 0.00, you would see a value of 0.9332. 0.9332. Now, this is obviously representing the area. Now you can see that it's actually intact because you can see the area now because we're dealing with a bigger area. The area is 0.9. That's a whole lot. All right. So look at what we're having here. The area here now, we're dealing with 0.9332. Now, let me now go on to answer, I think, probably a question that was written there. If you are told to find probability of Z greater than 1.5, of course, in that case now, the area of interest cannot be this one shaded. It will be this one shaded in blue now. So obviously, I told you already that there's nothing on your table. Your table, none of your table will give you a value from right to left. So you can get this directly from your table. So what you have to do is you just go on to do as I explained, 1 minus 0.9332. So if from here to here is 0.9322, and this whole place represents 1. That means this space here will be 1 minus 0.933. All right, just that simple. Now, can you go on to find this? Now that you guys have known what to do, I believe you can be more faster in solving. Guys, make sure you give this video a thumbs up if you're yet to give it a thumbs up. This is a new link, so give it a thumbs up, very, very important. Now look at the next question, 2.3. If this is 0, I can give 2.3 to this point. Now I'm dealing with less than. So if this is my 2.3, less than, obviously, this is less than 2.3. Now you can see that's a whole lot of area there. So I go on now, I go on to my table. This is how you use your table to solve this. I go to my table now, and I'm going to be checking 2.3 under 0.00. I'm sure you understand why. I'll be checking 2.3 under 0.00. All right. And 2.3 under 0.00, I can see it gives me, of course, this will be 3.20. And I can see I got a value of 0.9893 from the table, which is quite exact. Because you can see already that if I say this place is 0.9893, it doesn't look wrong because obviously I'm shading a whole lot of area from the whole curve. So you can understand that this is just the way it's just very great. So now again, the same way I've been saying it, if they told you now to say probability of Z greater than 2.3, now there is no table that will give you, if this was 2.3, if you're trying to look for greater than 2.3, obviously this is the area of interest in that case. But there's no table that will give you from right to left. So all you have to do is to go on to say you would go on to find for 2.3. That 2.3 you got from the table will give you for the left to right aspect, this part I shaded initially. So to get for greater than, you just do 1 minus 0.9893. Whatever you get there will be what the answer will be. All right. Now let's see for the next one. Can you guys do the next one? Let me give you like 30 seconds to start the next one. 30 seconds to start the next one. Now we can move faster now because I believe you guys are already aware of what's going on. So in this case now we're dealing with 3.38. So let's give somewhere here 3.38. All right. So we highlight this. We are dealing with less than. So obviously this is the area of interest. Now this is nice because this is how my table is being read. Normally it reads from left to right. So in this case now, I want to check for 3.3 under 0.08. Of course, that's what's going to give me a total of 3.38. So I'm going to be checking for 3.3 under 0.08. All right. So if I check for 3.3 under 0.08, I can see a value of 0.9996 from my table. So that means the area that this space occupy is 0.996. Sorry, 996. All right, 0.996. To my writing. Now, I still want to say this again because I want you guys to get very conversant with it. In the case where you are told to find probability of Z greater than 3.38, in that case now, you will be dealing with this area. Of course, this is, if you're trying to draw this, to sketch this curve, this is where you'll be shading in this case. Now, you don't ever get deceived. If you sketch this kind of scenario like this, where it's reading from right to left, and you're not interested in the left to right place, don't go on to check your table and say, the value I get there is my answer. That will not be correct. You'll be wrong. What you have to do in that case is to know that the value you will get initially from your table will be giving you the values from left to right. So for you to get this one, if this was the question you are being asked, the greater than 3.3, if this was the question you're interested in, the value you get from your table, the initial value you got, will be from left to right. So go on to, for you to get this one, you have to go on to do 1 minus 0.9996 in this case. All right, that's the way you deal with this. It's quite very, very all right. Now look at the next thing you have right there. 2.14. You have 2.14. That means, of course, it's very similar. Can you guys go on to find the remaining two? So you can use that to test yourself. I'll just go on to write the answer. Can you go on to get okay. So for you to get 2.14, of course, you know how to draw the diagram. Maybe I should just do it in case somebody is still trying to grasp this. So let's call this 2.14. Sorry, 2.14. So obviously, because it's less than, this is my area of interest because of the less than. So when I go into my table, I'll go on to find 2.1 under 0.04 because that's what is going to give me 2.14. So I check 2.1 under 0.04 and I'm going to be seeing, I think I can see 0.9838 right there. 0.983. I should think that's correct. Because is that what you guys got? Good. So this is 0.9838. All right. So this area that we shaded is occupying a total of 0.9838 out of the whole one area, the area being 1. So this is quite a significant portion, obviously. Now, again, as I will say, as I've always said, if you are told to find the probability of Z greater than 2.14, in this case now, you cannot get, because if you are to shade this, you'll be shading this portion. If you are to shade this particular question, you'll be shading this portion. And your table will never give a value from right to left, from left to right. So whatever answer you get as 2.1 under 0.04 will be from left to right. So what you have to do in order to get this answer will be to say 1 minus 0.9838. All right, and that's that about that. Now let's see the last but not the least right there. The z less than, or z less than 0.25. Of course, you want to draw your diagram. 0.25, let's put that a bit here. 0.25. So we draw it up, but it's less than. So obviously, we're interested in this. To find this, you have to go on to check for 0.25. Because that's what's going to give me a total of 0.25. You go on to check for 0.2 on that 0. You guys have not given this thing a thumbs up. What's up? You're so busy working. All right, take a moment to just give us a thumbs up. Very, very important. So 0.2 on the 0.2 on the 0.05, that will be 0.5987. So I got 0.5987 from my table. So that means this area right here is 0.5987. All right, and as I've always said, if you are asked to find, just in case you saw a different question that wasn't less than, let's say it was z greater than 0.25, how do you tackle this, guys? How do you tackle this? Of course, the diagram you would have needed to have drawn would have been the same thing, only that your shading would be different. If you're trying to tackle z greater than 0.25, you would have shaded this part, because this is what represents a greater than. Now, and I told you guys already, you can't get any value from right to left. Know that. So the values you will get when you go on to find 0.2 under 0.05 will be from left to, and that would have been the 0.5987. So for you to find this other side, you want to go minus 0.5987. That will be the value. So that's the way you tackle questions like this. Whatever you get now will represent the greater than. All right. So this is the last scenario which we're going to deal with. Just one. I'm going to give you just questions on that. Last scenario. This is the last scenario we're going to deal with. What if you have a question like this? That's a very vital one. Now you have z less than 2.5 less than minus 0, or let me do minus 1.5. How do you tackle questions like this? So let me give you, I'm going to do this. I'm going to give you guys to do the second one. Let me get this one to be 3.38. Let me get this one to be minus 2.33. So you guys are going to, I'm going to solve the first one, you're going to solve the second one. How do you tackle questions like this? Very, very simple. You don't need to sweat it at all. So the first thing is for us to identify our diagram, obviously. So let's go on to identify the diagram. This is the diagram right here. Of course, 0, minus 1.5. Let's give them, if this is, let's say this is 1, let's say this is minus 1.5, 2.5. This is 1, let's say this is 2.5. So, now, this is what we have right here. Look at what this is saying. Of course, if it was only greater than, you have shaded everything to this last point. Restriction said it's still less than 2.5. So your interest will be all this. This is your interest. So the question is now, how do we solve this? How do we get the value of this using a table? It's very simple. You don't need to sweat. It's very, very simple and straightforward. What you have to do is you're going to be using all the understanding you have known. Now, guys, let me quickly say this. If you go on to find 2.5 on your table, which you guys have already learned how to do using your positive table, if you go on to find for 2.5, I'm sure you know that the value 2.5 will give you will be the area from this place up until this place. Everything here to 2.5. That's what that area will give you. Now, also, let me ask you again. If you're going to find for -5 in your table, what area is it going to give you? Of course, it's going to give you from left till this right, till this exact point. So if you're finding 2.5, 2.5 will give you the area from this point. That means all this area now, it's going to give you all this place. That's what 2.5 is going to give you. All this area is what 2.5 will give you. If you find -1.5, -1.5 will give you all this place. Now, that's not all these things I've met. The two areas I just talked about are not your area of interest. This is your area of interest. So what you're going to do here is you go on to find for 2.5, get the value. Let's assume the value is 0.98 now for 2.5. Of course, 2.5 will be all this part till this point. -1.5 will be this part till this point. So all I need to do is to subtract whatever I got here from whatever I got for 2.5. Let me give you the exact. Let's do it exactly now. So I'm going to go on to find probability of Z less than 2.5. I'm going to go and find that first. So you go to your table now and find for probability of Z less than 2.5. Of course, you know how to do this already. You go and check for 2.5 under 0. 2.5 under 0 will give, if you look at it, you'll get 0.9938. This is what you get for 2.5. So probability of Z less than 2.5 is 0.993. The meaning of this is that, let me tell you the meaning of this. That means all this part I'm shading now in red, that's the area. All this part I'm shading in red, that's the area. Now, I will now go on to find for probability of Z less than -1.5. That's this place, from this place downward, probability of Z less than this whole place. This is the place I want to find now. This place, I'm going to shade this one in blue. This place here. This place I'm shading in blue is what represents Z less than 1.5, -1.5. So you can run quickly to your negative table in that case, because this is a negative question. So if you go to your negative table now, -1.5, we have 0. What we got there is 0.0668. All right. So this means that the area of 2.5 from here, all the shaded one I shaded in red initially before was 0.9938. For -1.5, the area, that means this one I shaded in blue is 0.0668. So obviously, these two are not my answer, because that's not what I'm interested in. I was interested in this one here. So obviously, what I want to do now is to say this whole place now will be 0.9938 minus 0.0668, because obviously I'm removing that of this less than -1.5 from that of 2.5, because if I take this out from the whole thing, I'll be left with the shaded, my initial area that I shaded, the interest area, and this will be my value. What did you get here? Can somebody give me the answer here? When you subtract these two things, what do you get? -0.9938 minus 0.0668. Of course, this would be 0.927. So this is your area of interest. This is the answer to this question. This whole question, this is the answer, 0.927. Just to give you a try quickly on what I did. What I did was, for me to find this inequality, of course, there's no table that will give you this thing exactly. No table will give you. You have to just use the understanding of how to find all the tables, all the values you have been doing. The understanding there is, of course, if you draw your diagram first, you want to identify your area of interest. We knew it was this portion in the middle that was of interest. So you want to go on to find for 2.5, less than 2.5, because you know less than 2.5 will be from here to this last end. Now you want to go on to find for less than 1.5 because you know 1 point minus 1 point, sorry, for minus 1.5 will be from here to the last end. Now I know that if I remove that of minus 1.5 from that of 2.5, what I'll be getting will be the leftover, which is what I'm interested in. So it's that logic we're going to use to always get questions like this. So guys, can you make an attempt to this second question before we call it a day or a night rather in this particular class? Can you make an attempt to the second question? How do you do it? Make an attempt quickly. How do you find the other one? For number 2, how do you find it? So for number 2, very quickly, of course, looking at the question, this is 0. 3.38, let's say somewhere around here, 3.38. Minus 2.33, let's say somewhere around here, minus 2.33. Of course, with what we have here, Z is greater than 2.33, greater or is less than 3.38. So this is your area of interest. Now, do you go on to just get this on the table? No, it's not possible. So what you have to do is to go on to find for the way I just explained. So you go on to find for probability of Z less than 3.38. Of course, that will give you all this from here up until this point, everything here. That will not be your answer. So Z less than 3.38, if you check that on your table, you should get, what did you get? That first one. That will be, obviously you're checking 3.3 under 0.08. 3.3 under 0.0, you get 0.9996. All right. I believe that's what you guys got, 0.9996. Now, if you go home to look for the other one, you want to look for probability of Z less than minus 2.33. So in this case, now you'll be using your negative table, and your negative table will be giving you a value of, you'll be checking, of course, minus 2.3 under 0.3, sorry, under 0.03. That will give you minus 2.33, obviously. You check minus 2.3 under 0.03, minus 2.3. What did you get under 0.03? I think I can see a value of 0.0099. 0.0099. So these are your two values of interest, but obviously this is not going to be any of your answer, because what I'm going to now do is to remove that of less than minus 2.33 from that of less than 3.38. So this place will be 0.9996 minus 0.0099. So what do you get when you subtract these two? That's going to be the answer you're going to be interested in. 0.9996 minus 0.0099. So you're going to be getting a value of 0.9897. So this answer, of course, the probability of this range of values is 0.9897. This is how you solve this. And this is going to bring us to the end of this class. Quite very simple. I'm sure you guys you have clarity on this. Can you give me feedback quickly? How do you guys feel? Were you able to really understand it? What's your feedback? Do you guys really understand it? I can see, okay, you guys got the answer. That's very great. All right. All right. Thank you very much, guys. Enjoy your night. Read very well. Wish you all the best. Bye.